റെക്കോർഡിംഗ് ഇടണോ വെറുതെ?
ലൈവ് ഉണ്ടെങ്കിൽ റെക്കോർഡിംഗ് ആവശ്യമില്ലല്ലോ.
Hello, Robin. We will start in a couple of minutes.
Yep, sure.
Welcome to Kiwi.
Thank you for having me.
Yeah. Just few more minutes. I invite sorry, am I audible now?
Yes, Arya, you are audible.
Yeah, Neelima, please carry on with this session.
Okay, so welcome everyone to an exclusive webinar on unlocking the data availability in blockchains. And we have with us Mr. Robin Roy, who is working as a developer relations at Avail. And just to give a brief intro about Robin, he has been previously working with, he has previously worked with Polygon IEEE P2145 standards working group. And he was also part of Gitcoin Kernel Fellowship and ETH India Fellowship. So with no further ado, I just welcome once again Mr. Robin Roy.
Hello, everyone. Hope you can hear me.
Yeah, you're audible.
Yes, you are.
Awesome. Yeah, so today I'm going to be, talking a bit about Avail and, what exactly data availability is. So before I think I start, I wanted to know a bit about, the audience that we have and how many of you have heard about data availability or anything, related to that. If you can like type it in the chat or raise your hand or whatever. Okay, we've got one person. Okay, cool. I think so. I'll have to probably get started from the basics itself, right? So yeah, let me just share my screen real quick, and it should be able to get started. Is my screen being shared?
Yes, it is.
Okay, awesome. Cool. Let me. Cool. So my name is Robin. I am a developer relations at Avail. Today I'll be, trying to, break down what data availability means in blockchains, which is a very core principle for any blockchain that you see. So yeah, let's just get started, right? So what are blockchains? So blockchains, it is a peer-to-peer network, right? A peer-to-peer network of nodes or clients that is maintaining a ledger. A ledger is just a ledger is just a record of transactions or some data saying that this transaction has happened from person A to person B or vice versa. Right. So we have all of these transactions, we have a ledger, we have a P2P connection among clients, all of that is great. But if you actually look at the core of it, right, what is actually happening in blockchains? Blockchains have basically three things that are, part of it. That there are three things that it's doing. One is execution. So execution എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ if you have person A who is transferring funds or some amount of money to person B, that transfer is an execution, like basically deducting the balance from person A and incrementing the balance of person B. That action, that operation is the execution, right? You're doing a state change from state A to state B. The differences that is happening here is the execution, right? And once you do the execution, you get state B, right? And then you have consensus and ordering. Now, what does blockchains do? Blockchains have a consensus mechanism Consensus means basically that if you have multiple people who are trying to maintain a single ledger, you all need to be aligned. Everyone should know that, okay, this is the order of how these transactions should be. And based on this order, we will do the execution. Because if I send 10 rupees to person A, and then I send 5 rupees to person B, but I have only 10 rupees total in my account, the ordering of those transactions matter. Because if someone else looks at these transactions and take my 5 rupee transaction first, then my remaining balance is 5, right? If I have 10 rupees and I'm sending 5 rupees to someone else, and I'm also trying to send 10 rupees to someone else, right? What happens here is based on the ordering of those transactions, my balance will change. For example, if my 5 rupee transaction is taken first, then my balance is 5 rupees, right? Whereas if my 10 rupee transaction is taken first, my balance is now 0 rupees, right? So it depends on the order of those transactions, and how do you determine the order of those transactions through consensus. So everyone in that network who's maintaining the network needs to have a consensus on the ordering. And that is what basically blockchains do. You have some mechanism to have consensus, and consensus on the ordering of the transactions, and then you execute those transactions. That is how blockchains work. But how do you get consensus on the ordering? So how do you verify later on that the execution was done properly based on the ordering that we have? That is where we need the data availability. Data availability is basically the data behind those transactions. Blockchains don't really know what is like, nobody else can actually verify the execution without knowing the data. For example, I can say that my suppose, yeah, like same example, right? If I had 10 rupees, I'm sending 5 rupees to someone else. Now the state change becomes that I had 10 rupees. Now in the new state, I have 5 rupees, right? How I became 5 rupees, you won't know unless you have the data behind my transaction of, sending that 5 rupees, right? So you need the data behind those transactions as well to make sure to verify if those executions was done properly. So that is how blockchains work in a very simplified way. It takes care of 3 things: execution, consensus and ordering, and data availability. So now we have so this was a basic explanation of what blockchains do. But now we have completely different paradigms. Like there are many different ways on how you can achieve this, because if you have used Ethereum or like any L1 layer 1 chain, right? It is kind of slow. It has high costs, like the gas costs are pretty high. And this means that, execution being slow, the cost being high, it is not good for anyone. So what did the Ethereum community do? They were like, okay, let us decouple, basically namukku separate execution from Ethereum. Let someone else take care of the execution. Let's speed up execution, and then let's settle back on Ethereum. Okay, the ordering and the settlement and all of that happens on Ethereum, but the execution happens on some other thing. So this is called as a roll-up, for example, right? A roll-up basically decouples execution from the settlement layer. So you have off-chain computation. But now the problem is you still need to put that data somewhere. The data availability layer is still Ethereum, which is still expensive. And 90% of the cost of a roll-up comes down to that sending that data, because you have tons of data. If you have tons of transactions happening, you have tons of data, and that data still needs to be posted back to Ethereum, which again causes, there are some issues with that. So it's costly. That is where now you have different constructions like validiums and sovereign rollups coming up, wherein you also use an off-chain data availability and ordering layer like Avail, for example, rather than Ethereum, and you just use Ethereum for the final settlement of the funds. Like Ethereum just makes sure, it just verifies if everything was correct and it settles the funds. But the actual data availability, where the data stays and where the execution happens, is outside of Ethereum. That's what a validium or sovereign is. I'm not going to dive into all dive deep into all of this right now, but we'll slowly get there, right? So let's understand the DA problem. So how can peers in a blockchain network be sure that all of the data of a newly proposed block is actually available? In a blockchain, like I said, you've got multiple people who has the ability to create a block, but how do you know that the data behind the block and whatever execution has been done is actually available? If the data is not available, then how do we know that the blocks might have malicious transactions which are being hidden by the block producer? And even if there are no malicious transactions, there might be some compromising to the security of the system, right? Basically, you want all of the data to be there and you need to be able to verify. Basically, the key word here is verification. How do you verify that something has happened without the data behind it? So in L1s, it is not majorly of an issue because all of the full nodes are anyway downloading all of the data. But when it comes to rollups or like off-chain execution, like I mentioned, the off-chain execution means that all of the transactions are being sent to the off-chain execution part. So in a rollup, if you have used like Optimism or Arbitrum or Polygon or Base or any other rollup out there, or you're basically sending transactions to an off-chain sequencer who is doing the execution and sending the data later on to Ethereum. But how do you know that? How do you guarantee that the DA layer or the data availability layer has access to all of the L2 transactions, right? Or how do you know that the ZK rollups or the optimistic rollups are actually functioning properly? So in ZK rollups, right, you need the data to recreate and advance the state of the rollup, and also for withdrawing funds from the rollup. And also in optimistic rollups, you need the data to create a fraud proof. I'll just pause right here just to make sure if everyone knows what optimistic rollups and ZK rollups do. Is there anyone who doesn't know what ZK rollups or optimistic rollups are? And if I'm going too fast, just let me know also. Anyone in the chat who knows what ZK rollups and optimistic rollups are, how they function?
So Robin, just to confirm, so in this rollups, basically there are two parts. One, there is something called a batcher, which will batch all the transactions and then push it to Ethereum as a call data or a blob, right? And then what the settlement means, what actually the meaning of data availability? I understand that the call data, the transaction data that is stored as a call data or a blob.
Right.
But what is the meaning of settlement?
Right. So settlement is actually simple, right? If you actually think about it, like at the core of it all of the rollups that you might be using today are just smart contracts. Like it is all smart contracts at the end of the day. So even if it is a ZK rollup or even if it is an optimistic rollup, it is just very highly complex smart contracts living on Ethereum itself. So those smart contracts are deployed on Ethereum, right? So that means whenever you are using a rollup, that means if probably you have used Optimism or Arbitrum, you are actually bridging funds to that rollup. So bridging is essentially just you are sending money to that smart contract, and that smart contract keeps a track of the balance, saying that, oh, okay, this person has sent 10 USDC to this smart contract, and hence in that rollup, you have now 10 USDC to spend, right? So now the settlement here is that the funds are in that smart contract, and whatever transactions whenever the batching happens and the state update happens, right? That balance is also getting updated. So the settlement of those funds are actually happening on Ethereum in a sense.
So when I consider just a bridge contract, what is the difference in here? Let's say if there is a bridge contract. Using the bridge contract, I'm just holding the funds tokens and then creating the new tokens on the other side. And then there, if I have to withdraw, then there I will burn it, and then here I will release it.
Yeah, same thing.
So the rollup also same thing.
Yeah. Rollup basically, the thing about rollups is every rollup has a native bridge. So
Okay.
basically, by using the native bridge, you are basically submitting some funds that you're locking it in the Ethereum smart contract and minting it, quote unquote, on
Rollup.
right. So on the layer 2. So essentially, it's a native bridge. So it's basically a trustless bridge, you can say, right?
Okay.
So that is why you need to have withdrawals. That's why in optimistic rollups you have a 7-day withdrawal. The settlement happens on that layer 1. In optimistic rollup, for example, even if you are using the chain, whatever, if you want to withdraw, it takes 7 days to withdraw your funds, because that is the challenge window period that the optimistic rollup has given for anyone to create a fraud proof. If no one has given the fraud proof, it is considered settled, and like the withdrawal can be done. Right. So that is what I mean by
But
settlement.
then some people say that in optimistic rollups also we can use certain bridges and then we can get
Yeah.
the
So
instant withdrawals. What is
yeah.
that
So
difference?
yeah. So now it is. So when you use, so that is the problem of marketing. Basically, it is not a trustless bridge there. You are trusting a relayer, or basically someone else is taking the risk for you. What is
Okay.
happening is you are sending money to that bridge smart contract, and some relayer will send you the funds instantly on the L1 or L2, wherever you're bridging towards. And they are taking the risk that they will wait for the 7 days to withdraw the funds later on. Right.
Okay.
That is, so it's basically, yeah, they are insuring it for you. Right. So that is what essentially happens. But if you want to use the native bridge, it takes time. So yeah, it's basically UX thing there. So yeah, so let's, I guess, move on from that. And just to keep moving forward here, we have ZK rollups. What do ZK rollups do? You have all of these transactions from users. They are batched. A proof is created of that of the state differences, and it is being sent back to L1 or any other data availability layer, where the data, basically the data still needs to be there, because just having the proof does not allow you to do anything. The proof allows you to verify if the execution was done properly, but later on, if you want to reconstruct the state of the rollup, or if you want to do L1 withdrawals, you still need all of the data behind it to reconstruct what the state of the chain is, because just with the proof you cannot do that. So that's why data availability is important for ZK rollups. And for optimistic rollups, pretty much similar, not pretty much similar, but like you need the state, or you need all of the data transaction data to be able to prove any fraud, right? If any malicious transaction has happened, you need to create a fraud proof. And in order to create a fraud proof, you need the data behind. If the data is not available, you cannot create a fraud proof, and then hence you cannot prove anything has gone wrong. So it is very critical for both types of rollups that data is available. Okay.
Can I ask one question?
Yeah, sure.
So when we are saying this fraud proof, basically whatever transaction data which is posted onto the L1 will be taken and then re-executed, and then if there is a difference in the state root, then it will be reported as a fraud. Is it correct?
Yeah, I mean, the implementation can vary to different rollups. Essentially, they'll just they'll look at the data, they look at the state, they try and figure it out. If there's anything wrong happening, if there is a mismatch between the state and the data that has been given. That is why I mentioned there is this consensus and ordering. There is then the data availability. You need to make sure the ordering is correct and the data behind those transactions are available. If both of them are correct, then you can make sure the execution was correct. So how the implementation is, it differs, but the core principle is the same.
Okay.
Right. So again, this is the same thing that I will, in a more diagrammatical way. If Alice is sending Bob $10, what usually happens is Alice is basically publishing that transaction to a ledger, and Bob will check the ledger and be like, oh, okay, I have got the $10. Great. Now, again, in the blockchain world, you are publishing the transaction to a set of validators or the nodes who publish this ledger from time to time, and you can later on check and say that, oh, I have that $10, right? So whenever someone wants to check Bob's balance, they ask those nodes, and they'll be like, oh, okay, according to the state of the ledger right now, Bob's balance is $10. Great. That is in the monolithic sense. Now, when it comes to, again, a roll-up, what happens is Alice publishes this transaction. The roll-up now, who's this off-chain sequencer, who's getting these transactions, they check if the transaction is correct. Like, hopefully, it checks if the transaction is correct, unless it's a malicious sequencer. Usually nowadays, we trust the sequencer in a centralized sequencer setup. Basically, it verifies the correctness and it publishes the batched updates. It batches all of this up and sends the updates back to the L1, right? And how does Bob check it, right? Bob needs to check if this was correct only, and he can only do that if the data is available. And basically sending these updates, like, for example, sending all of the transaction data back to this L1 can get very expensive. So that's what I've shown here, right? So the most simple solution here is, instead of posting all of the data, that this can be MBs or GBs of data per day to Ethereum or the L1, you can post the data to some off-chain DA layer or an alternate DA layer that is optimized for having cheap data availability. And the DA layer basically posts attestations which are back to the L1. So basically now just think of it like a proof or an attestation saying that, hey, I have this data, right? Whatever execution that has been done by this rollup, the data is being sent to the DA layer, and then you have the execution layer updates. If it's the ZK proof, the proof is being sent. Maybe the state update is being made on the L1 for optimistic chain, but the actual transaction data, which is the bulk of the change, that lives on the DA layer, and the DA layer basically sends an attestation saying that I have this data with me. You don't have to worry about it. If you ever want to check it, you can come in and check it yourself. You can look at this attestation and maybe you can retrace it back to the DA layer where it is posted. And that is how kind of like DA layers kind of work, right?
So basically, we will be trusting that particular DA layer, right?
Yes. So in a sense, so like obviously this attestation that is happening can happen in a trustless manner, and I'll go into how Avail does that. So there are obviously trusted and trust minimized ways to do it, and I'll be going into how Avail does it, which is more of a trustless manner, right? There
So
are
in the L1 contract, only the attestation signature will be verified.
yeah.
Okay.
I mean, you can read the data from the DA layer itself, but if you just want to verify the attestation, you can just basically we use ZK proofs to do it. So you don't have to like do a lot of computation. You can do a ZK verification, and you will be able to do it. And I'll be showing that soon. So let's look at the general picture right now. So we've understood what the DA problem is, what the data availability problem is, and there are 4 different approaches to actually solving this issue, right? So you might be thinking about, okay, this DA problem why has it come up now? Wasn't it an issue before? Because approach 1 is, before we didn't have rollups and L2s. Before we only had Ethereum, which was a monolithic chain, and execution was done by all full nodes. And then we had all these call data and blobs, and we realized it was expensive. Then off-chain DACs came in, and then decentralized DLAs came. Let's go through that, right? So the first approach is execution by all full nodes. This is the monolithic approach, wherein you have a decentralized network, basically a layer 1, where there is no rollup. All of the transactions are happening directly on the layer 1 chain. That means all of the nodes are picking up all of those transactions. They are executing the transactions, and they are updating the state. These are full nodes on the layer 1 level, right? And hence the data will be always available. There is no issue of data availability issue because the transactions are not being done off chain, right? So this is great, but we understood that this is not scalable. So what did people start doing? They started doing off-chain computation and started posting data back to Ethereum for this. This scaled execution, right? This scaled execution, when you decouple execution from the main Ethereum chain, you're able to scale execution, but the bottleneck now becomes the data availability part, because you cannot verify the execution unless the data availability layer has that data, right? So since Ethereum was slow, the DA was slow, and hence, rollups still couldn't scale as much as they could, right? So what is call data and blobs? Essentially, all of the data that was being submitted was being submitted back to Ethereum using a method called as call data. And now recently in March 2024, a Denken upgrade was made, which introduced blobs or EIP 4844 blobs, which is part of this proto danksharding or danksharding roadmap. Essentially, it gives you the ability to submit cheap data back to Ethereum, and it's no longer part of the execution client. It is stored in the consensus client of Ethereum and all of that good stuff. I can dive deeper into it if you want to. But essentially, all you have to imagine is they brought in a new data type that allows you to post data to Ethereum cheaper. And this reduced a lot of the costs for rollups today. But if L2s keep, if L2 demands keep growing, we expect that, within the next, 2 to 3 years, the fees or the cost to send blobs will again be high, and that will again, the cycle repeats. So this is another one approach. Now the next approach is we can do it in a Hello? Sorry.
Audible.
Okay, yeah, sure. So now we have approach 3, right? So we have an off-chain data availability layer, and we can do this by a data availability committee. So instead of posting data to Ethereum, which is a decentralized layer 1 layer blockchain, we can have an agreement between a few set of nodes saying that, okay, these nodes will keep the data for you, and whenever someone requests for it, they will send the data back. Now, the issue with this is, how do you trust this data availability committee? It's basically a very centralized group of maybe 10 nodes or 15 nodes who will keep the data for you. Obviously, they might have some cryptographic base that they can sign that I have the data or not. For example, you might have heard of EigenLayer or EigenDA, which is a DAC. It is a data availability committee wherein you have 200 operators, 100, 200 operators who are keeping the data, but you have no ordering guarantees. You have no other, you have no guarantees basically on if they are actually holding that data or not, and if the ordering of that data is maintained or not. They just have cryptoeconomic guarantees, right? So cryptoeconomic and reputational guarantees is what they provide, what DACs provide, and that is very cheap to do, because now you don't have, because it's all living in some off-chain component, you don't have to think about it. It's very cheap to do, but there are trade-offs wherein you have to trust this DAC to actually hold that data. Hopefully that kind of makes sense. And then what is the middle ground that we have? We don't want it to become centralized, but we also don't want it to be expensive. What is the middle ground here, right? The middle ground is to have a blockchain DA layer that is hyper optimized for data availability, and which can use data availability sampling or not use data sampling. And I'll go what data DAS means soon. But essentially what happens is, we have an off-chain component, but this off-chain component is a layer 1 blockchain itself, or it is a blockchain itself that has its own consensus, validator set, and other security guarantees that gives it both cryptographic and cryptonomic guarantees, right? So in case of Avail uses validity proof technology like KZY commitments and light client data availability sampling to ensure that this data is available. Essentially, we make that DA layer component more decentralized rather than having a centralized DAC, right? So hopefully all these 4 approaches make sense to all of you right now. If not, let me know.
One question, Robin. So basically, this ensures that our transaction data is available always, right? So why can't we use? I think there will be some difference. I want to understand the difference. So if we can use the Filecoin to just push the data, right? So that also, let's say, can ensure the data available, right? So how that is different from this approach?
Right. That's actually a good question. So there is a question between decentralized storage versus data availability, data storage versus data availability, right? So the main difference here comes in of one is Filecoin is more catered towards content that can, it's mostly content ID and stuff like that. And also it does not guarantee ordering of data. What a DA layer should also preserve is not only the data, it should also preserve the order in which that data has come. When it comes to a DA layer like Avail or Celestia or whatever, but basically a DA layer, right? You should also maintain the ordering in which it came, which a normal decentralized storage solution cannot. And also the state bloat can also be very high. So in Filecoin, once you put that data, it is there forever, even if you don't need the data. So state bloat is also there. Whereas DA layers often prune this data after maybe 30 days, because once this particular challenge, once a particular period of time is over, that data is no longer needed unless you need to archive it. So archiving is where you can put the data on a storage layer, and it does not provide as many guarantees as a DA as a layer that is optimized for DA provides you, which I'll go deeper into, like what DA is and all of that does. But Filecoin and all of those, they don't provide those guarantees as much as a layer that is focused on DA does. So those are kind of the differences. Basically, it is just the ordering of the data, being able to preserve the ordering of the data, and by preserving the ordering of the data, we are able to preserve, the canonical form of execution. Basically, you can verify the canonical execution.
Okay. So another question is, so in general, the expectation is for a long-term storage, archival storage, the roll-up network is responsible for keeping the entire data for the old data, archival data. How it is generally done?
I mean, that depends. That depends on the roll-up. They can host their own nodes and archive the entire data. They can use third-party providers, all of that. So it's usually not that hard. Like, you can just get the data and then just store it for later use. Usually, roll-up teams work with providers like Alchemy or stuff like these teams who will probably archive the data for you, and then you just have to pay a fee for it.
Okay. Okay. So for the DA layer, this DA layer part, the expectation is only for certain period of time, the data will be maintained here. Correct?
Yeah. So, I mean, like, for example, the most time you would need is maybe 14 days, 7 days or 14 days for optimistic rollups, right? Once that challenge period is over, if that data is available or not doesn't make a difference. So after that, you can prune the data. Like,
Okay.
right? I'm talking from a functional perspective. Obviously, you would want this data to be archived so that you can use explorers or use a historical data or some other stuff. But this is from a roll-up functioning perspective. You don't need the data for more than 7 days or 14 days. So that the DA layer is optimized for just DA, and that is why the costs are also minimal, right? Running a validator doesn't have a lot of state bloat. Posting data doesn't cost a lot of money. All of that is partly because it is optimized for data availability only. And then later on, storage comes in different part.
Okay. So the blob also is a similar, right? So
Yeah.
where exactly the difference comes for somebody is the cost is the only factor to decide between blob and the DA.
So blob, I mean, Avail, so blob is just a data type, right? So like,
Correct.
I mean, Avail, whenever you send a data to Avail, that is also a blob, basically. You can kind of call
Blob in the sense like Ethereum blob, I mean to say.
Right. So the main differences come here is cost is obviously one thing. The finality time for Ethereum is sometimes 12 seconds, and like the complete finality might take a few more minutes, right? So 12-second blocks with even more time for finality. It's just slower for some chains for days. So like I mentioned, the real bottleneck for rollups is not execution. It is
Correct.
database.
Storage.
It is the availability of that data, right? If you look at Mega ETH, for example, Mega ETH is supposed to be this giga gas, like it is high throughput beefy sequencer. They are running like a very massive server, centralized sequencer, and they want super fast data availability guarantees, and hence they can't use Ethereum for DA. They use some other layer for, right? So that is also another reasoning. And Ethereum right now, with just blobs, does not provide all of the guarantees that it wants to provide. Blobs are just a precursor to what they are planning to do called as dank sharding, wherein you have light clients which can sample the data and provide cryptographic trustless guarantees of that data availability. Right now, you still need to rely on the full nodes to fetch that data from, or to make sure that the data is properly stored. You still have to run a full node to make sure all of that is happening, or you have to trust a full node. So that is the case in Ethereum. Whereas in Avail, what happens is we have implemented everything that Ethereum wants to do in the next 5 years through the dank sharding roadmap, such as light client sampling and all of that. So we have the KZG commitments that blobs use already today on Ethereum, but we have also implemented light client sampling of data. So I mean, those are the kind of the differences, right? What do you have today versus what does Ethereum have today? Is, I guess, the difference.
Okay, thank you.
Yeah. So yeah, I guess I'll move on to like why Avail DA scales. Again, I'll go to the same example. Alice is publishing a transaction to someone, and the validators publish the data in a monolithic sense, and in a roll-up sense, it is talking to the roll-up, sends the data. The data is being sent back to now the data is being sent to Avail, and that attestation is being sent here, right? Now the DA validators publish this data. So whatever data is being sent here, like in this step from the roll-up to the DA layer, we are sending high quality, or like high quality means like basically you are giving really good DA attestation with really good guarantees that, okay, I have that data with me. And now you also have some light clients. That is, light clients are basically very light software that can check on the network, right? Now I'll talk about why that is different is, but yeah, so essentially light clients can basically verify if that data is available. And now one thing I also want to maybe mention is that every base layer will be a DA layer. Ethereum is on its way to become a DA layer. Avail is a DA layer. You've got Near, who also launched Near DA. They are also trying to become a DA layer because data availability is how blockchains function at the core of it. And here are some of the reasons why Avail kind of works, right? So basically, I'll talk. So basically, now I'm going to talk about how we ensure that data is available. So obviously, we have our full node network and all of that. So we have a validator set. We are a layer one blockchain that is hyper optimized for data availability. But let's imagine the case of data coming to Avail, right? Now, a rollup now sends data to Avail. Now, what happens is that it is easy for anyone to hide data still. Like in the sense that if you send data to someone and you want to hide, so imagine this is like a set of data, and you have, out of all of this data, the person who is sending this data, or like, the validator probably wants to hide this red block. They are like, oh, I need to hide this. I'll send everything else except for this. So it is easy to hide a chunk of data, right? And nobody will notice. Now, what Avail does is that whatever data we get, like we take all of this data, we create a block, and the block data is then erasure encoded, right? Erasure encoding is just a way for us to ensure data redundancy. It's like the same thing that is used in like CDs and disks back in the day, when like even if you have scratches on the CD, you're still like, even if you lose some data, basically, like if someone hides the data or if anyone scratches that CD, you can still play it and it still works. That is what data redundancy happens means, right? So like in the same way, the block data that is received on Avail is then erasure encoded such that you cannot just hide one chunk of data, right? Because what you get out of doing erasure coding is that if you have, suppose this is n number of data, and you erasure code it to become 2n number of data in such a way that you can retrieve all of the data by having any of the n blocks. So if you have any n chunks of data, you're able to retrieve all of that data, right? So in that case, now you can't just hide one or two chunks of data, because if anyone fetches this also, and if they fetch any other n chunks of data, they are still able to verify all of that data, right? So if you are a malicious person, you will have to hide n plus one amount of data to actually hide the data that you want to hide. So even if I want to hide just this small part, I need to hide n plus one chunks of data to be able to hide just this one part, right? So because of that, it's very hard for anyone to hide data and keep data unavailable. Hopefully that made sense. Let me know if you have not kind of grasped it. Chat. Okay. Hopefully, I think everyone got that. So this is it. Did we solve all the issues related to DA? Did we do data redundancy? Was that the only issue that we needed to solve for? No, because erasure encoding can happen. So we can erasure encode the data, but the encoding itself can be done incorrectly by a malicious party. Or hello. Sorry. Okay. Yeah. So I was saying that erasure encoding itself can be done incorrectly. It can be done intentionally or non-intentionally, but that does not matter, right? If the encoding is done wrongly, then that causes a problem. So what does Avail do? So what Avail does here is basically shown in this diagram is we have this original data you see on the top, right? And then we extend the data. Basically, we do erasure encoding, and we from the n is to m matrix, we create a 2n is to m matrix, right? We do that. We do an erasure coding and extend that data for redundancy. Now, to ensure that the encoding is done properly, what we do here is we take row-wise commitment. So imagine all of the data is arranged in a matrix format. And basically now from a n is to m matrix, we have now made it into a 2n to m matrix. And now you take every row's KZG commitment. So there are different approaches to this. For example, there are some teams that use hash-based commitments, but the problem with hash-based commitments is that you'll always have to recompute the block in order to verify if it was encoded correctly. That means you have to rely on full nodes. Whereas now use KZG commitments is basically validity proofs. It is like a precursor to like ZK proof. So like by using KZG commitment, what you can do here is you can create row-wise commitments of this data, and you can verify, like for example, you can, because KZG commitments are also homomorphic, you can basically verify if it was done correctly. So if you have C1 to Cn, you can verify Cn n minus 1 to C2n. So n plus 1 to C2n is done correctly, right? So you have that as well. And also what we do is we take these commitments, all of these C1 to C2n, and we add it to the block header. Now, why we do that, I'll mention soon. Basically, just imagine you have all of that block data. You've erasure encoded the data. Now you've taken row-wise commitments, KZG commitments of this data, of this data, to make sure that the encoding was done properly. Now, with all of these commitments, we extend the block header. And why we do that is because we want to do data availability sampling. Now, data availability sampling is basically just a way for light clients to say that, okay, I've got this light client that will sample the network. So in a general sense, right, on Ethereum or any normal blockchain, light clients, what they do is they don't take the full block data. They just look at the blockchain and they just fetch block headers and verify if that block header was correct, right? So that is fine. But the problem is in the normal sense, Ethereum light clients or whatever, they still need to trust the full node to ensure that the block was actually properly created, right? And like it's not a malicious block. It cannot check by itself if the block is malicious or not, right? So yeah, so that is an issue with the current Ethereum architecture. And what Avail's light clients can do is, because now we've taken these commitments and we've added to the block header, right? Now what light clients can do is it can talk to a full node, or it can talk to a node and be like, hey, for the latest block, give me, and remember, these are all matrices. So give me the data at the cell 1, 2, 3, 4, maybe basically it picks randomized cells or within the matrix and ask the node to give data particular to those small chunks. So imagine we are having data that is in a matrix like this. It is kind of sampling randomized parts of the data. And because you're sampling random parts of the data, you cannot hide that data easily, because again, if you want to hide the data, you have to hide n+1 chunks. So if you're hiding n+1 chunks and light clients ask for this hidden part of the data, you have to show it. You cannot hide it, because then the light clients will know that something is wrong and will reject the block, right? So now you can randomly sample chunks of blocks of the block data. And now because light clients only look at the headers of the block. They don't download the entire block. They're just downloading small bytes of data from the entire block. They look at the block header, and the commitments are there on the block header. It's KZG commitment. So basically, they check against the commitments if that data that was given to them at this particular cell matches the commitment that is there in the block header. So they open the KZG commitment and they check if the data is correct. So basically, now the light clients can verify trustlessly if the block is valid or not. This was not possible. This is not possible before. And this is something that Ethereum is planning to implement 5 years down the line in the Danksharding roadmap, but Avail has done it already today, right? So this is how an Avail block looks like and how light client sample. And now you might think like, how does maybe sampling like 5 small pieces of the block help in verifying that the entire block data is available, right? So this, it comes down to probabilities or basically statistics, right? So imagine you have this block of data. So imagine all of these blocks or these balls in this box are data, right? And the thing here is, every time a light client comes and says, hey, I want to sample the data at this particular, like maybe 1:5 cell, I want to sample that data. Give me the data behind it, right? And there's always a 50% chance of that data being hidden or available, right? If it is available, that data is being sent back to this thing and it is verified. Okay, great. So that's a 50% probability done. And I again sample it. So there's a 50% into 50% chance. So each time, the more times you sample, the probability to fool the node after the 7th iteration, according to this image, you can see is 0.007. So what our light lines do is we do around 8 to 10 samples. And with that, the probability is so low that we are pretty much 99.99% guaranteed that by just sampling 10 small chunks of the entire 2 MB block that Avail has, by just sampling like around a few bytes of that data, you are able to cryptographically and probabilistically say that that entire block data is available, right? And this scales non-linearly with the block size. So like even if the block size increases, you don't have to increase the number of samples. Even with, suppose right now the Avail block is 2 MB, even if that becomes 1 GB blocks, you can still just sample around maybe 10, maybe 15 samples, or maybe even 20 samples. You're able to get the same guarantees, even if the block scales as big as 1 GB blocks, right? So this makes the light client resources very light, and you can verify trustlessly. So you can embed light clients into a wallet, into the browser, etc. Hope that makes sense. Is there any questions about data availability sampling?
Yeah, Robin.
Yep.
Are the light clients, so if a user is like running a light client or something, are they incentivized?
Not really. The light clients are not incentivized to do anything. It is mostly, so yeah, it is mostly to verify it yourselves, right? So we don't expect anyone to run a light client. So if you want to run a light client, you can, but you're not incentivized to. You only run it if you want to verify the network. So if you are a project that is using Avail, for example, and you want to maybe verify stuff, right? You can use the light client to do so. Or if you are a wallet, so we can see a lot of, we are talking with a lot of wallets, embed Avail's light client. So now any rollup that uses Avail, the light clients can kind of, it runs in the background and verifies if all of those block data was correct and all of that. So it is not incentivized. It is just an add-on if you want to have extra security.
Okay. Yeah.
So basically, the owner of the data, like roll-up operator, will be checking.
Yeah, I mean, anyone can check in. It's trustless, right? So basically, if you want trustless guarantee of the data to be available, you can run a light client. That is all there is. Right now,
So main the roll-up operator will have a more motivation to do
Yeah.
because he is the owner of the data.
Yep. All right. So now we also have block space multiplexing. That's a big word. All I'll say is our blocks itself are in a matrix format, and we allow for blocks to have multiple different namespaces or like spaces within the block. So if you are a rollup, like I have a rollup called as Robin Chain, right? Now, if I want to post data to Avail, and I want to maybe later on retrieve the data that I've posted, I don't want to be, because multiple rollups will be posting data to Avail. I don't want to download all of the different rollups data, right? Because that is going to be like a huge amount of data for me to, download and then process. I just want my own data, right? So what Avail does is Avail allows you to have an app ID or an application ID, which means that, and also all of the data that is being sent is basically segmented in that way. So the data is partitioned according to application IDs. So if I send, suppose I have application number 7 or app ID 7, then whatever data I sent via app ID 7 will be, demarcated in the block data like that. So whenever I query the data from the block, I can just say, filter for app ID 7's data and give it download only that data. So that is a cool feature that we have that no other data layer, like Ethereum probably does not have. So yeah, we provide that as well. So you don't have to do anything in terms of downloading the entire block. Even the light clients support this. So if you want to just sample and reconstruct the data of your particular app ID, you can do that using the light clients as well. So you don't have to, again, use a lot of resources to kind of for other rollup data. And now what makes us decentralized a bit more, like, again, these are all really good add-ons to make the layer more decentralized and more secure and trust minimized, is our light clients also maintain a light client. So all these light clients talk to each other in a light client P2P network. So if I have a light client, you have a light client, someone else has a light client, our light clients have a P2P network where they're communicating and they're sampling the data from the nodes, right? Now what happens is these light clients also maintain something called as a distributed hash table. So basically it's a peer-to-peer maintained database, you could say, of the Avail network. What that means is that now each time I try to sample a block, the light client, the light client first samples the DHT. It checks if the DHT has already the data or not. If that data is not there in the DHT, it calls to the full node of the Avail network and asks for the data and verifies through that. And then it puts the data onto the DHT, right? And this means now we have a decentralized secondary backup for this data. Right now, all of these light clients are doing this. What this means is that if the data is already on the DHT, it samples the data directly from the DHT, checks against the headers, and makes sure that everything is okay. If it is not already on the DHT, it queries the full node and makes sure that it is added to the DHT later on, right? And in that way, if you have multiple light clients working at the same time on the same block, for example, right? Suppose you have 100 chunks of data and you've got 10 light clients randomly, not even 10, maybe 100 light clients randomly sampling this 100 chunks of data, right? And each light client is sampling like around 10 to 20 samples. There will be some overlap because it's randomized, but there'll also be a probability wherein almost the entire block is completely sampled. Like the entire block has replica will be on the DHT, because every time it is querying the full node, it is recording it into the DHT. And that means the block replica is later on available in the DHT, right? And what it allows you to do is that even if the full node Avail DA network is down, it has gone, maybe it is unavailable, or if the validator set has gone down, then some black swan event has happened, up to the last finalized block, that data is still available via the light client P2P network in a trustless manner. So you don't have to rely on the full node network to get the data back. As long as that DHT is available, you will have up to the last finalized block. So hopefully that makes sense. And then what do I mean by the full node network? Basically, Avail has is a substrate based network. Substrate is taken from the Polkadot ecosystem. It is an SDK where you can build your own blockchains. So Avail uses the substrate network, which is similar to Tendermint, but it's like Tendermint, but for created by the Polkadot team. It uses substrate to function. It uses the babe and grandpa consensus mechanisms for finality and liveness. The babe is basically a block assignment or block producing algorithm, and the grandpa is a finality gadget which allows you to get finality. So babe creates soft finality guarantees, and grandpa gives you full finality guarantees. And hence, even if finality does not work, you have liveness through babe actually producing the block. So liveness is guaranteed, and later on when grandpa catches up, it gives you full finality. So we use a hybrid consensus mechanism for our full node network to actually work. And yeah, it uses a NPOS or nominated proof of stake system. So the validators stake for validating on the network, and then people can nominate or delegate their stake to any validator set that they seem right. So that is there. And then finally, I think we had a question about how do we get this data, securely on back to the settlement layer. So this is taken off from L2Beat, which is a really good website if you want to check out, anything about rollups. So basically, you have this layer 2 sequencer that batches the transaction data, and it is, you can either have the data on chain. If it is on chain, like it is being sent back to Ethereum, it is being sent as call data or as blobs on the consensus layer, or else you have external DA off chain. You have dedicated blockchain that like Avail DA, or you can have an off-chain committee like a data availability committee, whichever way you choose. Basically, that data is off-chain from the settlement layer. You have DA attestation that is being created, and there will be a DA bridge. Basically, there will be a contract on the settlement layer that will store this attestation. Attestation can be ZK proofs or something else, but essentially it is an attestation that the data is available on the off-chain component. So yeah, I mean, like this is how it would look like. You have your rollup, you have Ethereum as settlement layer, you have your data availability layer. Let's replace that with Avail DA, which is scalable data availability, and there is the attestation being sent back to Ethereum. This diagram kind of shows again everything really quickly. You have a sequencer where all the transactions are. You get the transaction data sent to Avail. You get a block reference, or like the block reference back to the sequencer sends, okay, I have this block reference, and then the attestation which basically attests to that block, saying that, hey, it's there in this block. So yeah, I mean, that is pretty much all I wanted to cover. I know we took 1 hour. So yeah, let's maybe take 10 to 15 minutes if we have any questions, or if there's anything you guys want me to repeat, I can do that as well.
Robin, one question I have, compared to this ag layer from Polygon, how it is different to here data availability? I didn't check the ag layer, but can you compare where it stands?
So ag layer is not a data availability layer. It is more of an interoperability solution for cross-chain communication. So yeah, I didn't actually mention this. Avail also works. Avail is not only about DA, actually. So this entire session would actually be kind of invalidated a bit, but like we have also a couple of things that we're working on called as Nexus and Fusion. Let me try and I mean, so we have what we're building called a unification layer. So we have Avail DA is what I was talking about today. And we have Avail Nexus, which is more of an interop solution. And this is more akin to what ag layer is also building. So ag layer is like this ZK-based proof aggregation system that allows you to have seamless interop between multiple different L2s. Similar what Avail is also trying to build with Avail Nexus. Basically, the main idea here is to address rollup fragmentation. DA is not for addressing rollup fragmentation. It allows you to scale rollups. And then because of scaling rollups, now we'll start seeing more rollups every day. and hence there is rollup fragmentation, and we want to solve for that. And then we have Fusion that will provide unified economic security for it. But yeah, I mean, AgLayer is not comparable to what Avail DA does. It is more comparable to what Nexus does, which I haven't covered in this talk.
Okay, basically, the liquidity among those rollups can be provided with the ag layer on Nexus. Right? So let's say I have some assets on one particular rollup. If it is a part of this Nexus, then I can withdraw from some other network. Is it like that?
Yeah, I mean, anything is possible. So how we are building Nexus is that obviously you can have unified liquidity. That means you can, even if you have funds on one chain and you're using an application on another chain, you don't have to actually go through a bridge it first, wait for that finality, and then go and use the application. You can just use the application directly, and everything else happens behind the scenes, kind of like chain abstraction. But yeah, it
Okay.
is a bit more
So
nuanced,
the
more
like
decentralized.
with this probably there could be an hybrid applications where it can interact with two rollups like that is possible with this.
Yep. Yep. So
Okay.
I mean, I like this, like we were talking about data availability too, so I didn't go much into Nexus. But essentially, what we are doing is asynchronous composability can be done. So like contingent execution. So like,
It's kind of in Polkadot there is something called XCM, right?
XM.
Cross chain
Yeah.
similar.
So I mean, yeah, everyone is building similar stuff. Like, see, at the end of the day, the like ideas converge, but
Hmm.
implementation differs. Um, I mean, contingent execution for us would look like wherein like Polkadot XCM works only within the parachain ecosystem.
Correct.
As what we are trying to do here is we are trying to connect any blockchain to any other blockchain. So if you have an NFT marketplace on one chain, and then you have payment focus chain on another chain, right? And you can maybe be on this NFT chain, you can click buy, and then behind the scenes there is a coordination happening between these rollups using zk proofs or like optimistic guarantees or whatever. And what happens is like there is a promise being made of payment, and there's a callback once the payment is made. On the other chain, the callback is being made saying that, oh, okay, here's the proof of inclusion of the transaction on the other chain, or if the payment is not made, a proof of non-inclusion. So basically we're trying to build a web2 like user experience for people without actually switching chains, right? So
Also, it is very similar to the Cosmos IBC also, right? Similar thing.
IBC kind of works differently. I'd say it is more for only bridging rather than just
Okay.
any arbitrary use case. So Avail Nexus is, you can think of it as arbitrary message passing, and you can do bridging, but it is not limited to only bridging of assets. You can do any kind of cross-chain communication.
Messaging, basically the
Basically
messaging
message
between.
passing, yes. Message passing and proof aggregation, or like, yeah. What Nexus does is we have two components. One is an optimistic component for high value, high trust networks. And for any long tail assets, we have ZK Nexus, which is basically a way for like you take the proof of executions, like you take the ZK proofs of all the different chains, you aggregate it, and then you can verify that the execution of all the chains using just this one single proof. And by doing that, now you are able to kind of do all sorts of coordination, because now you just have to wait, you just have to verify the single proof, and you can ensure that the execution has been done properly. So, and then, yeah, there is other stuff that we are also working on that front.
Okay, can you go to the first slides where you mentioned the layers?
This one?
Yeah,
Or this?
this one. Yeah, third one.
Okay.
So what is this? The last two okay, data availability. I understand. What is the sequencer?
Oh,
You
okay.
mentioned here two boxes, right? So one is the data availability. The other one is
Ordering.
ordering, and data availability is a part of it, right? The same
Yes.
thing, right?
Yeah.
So what is the last block?
This one, sovereign rollup.
The, The Avail, just you mentioned Avail logo, right? The bottom.
Yeah. Okay. So you're kind of asking what this is, or you're asking what this?
Yeah. What is this block?
Okay, so basically in this, what we're trying to mention here is who's taking care of what, right? So in a monolithic chain, you have execution, settlement, ordering, and data availability all handled by the Ethereum chain itself.
Correct.
When it comes to a roll up, you have the execution handled by the off chain or whatever,
Correct.
ZK, optimistic, everything else. Validium is just another word for a roll up, but in this world, what happens is the ordering is done either by Avail or a sequencer, and the data availability is done by Avail, right? Okay, now the question might arise, what is this meaning of Avail or the sequencer, right?
Hmm.
Here, what happens is the sequencer, in a general sense, for most rollups out there, the sequencer decides the order of the transactions and it posts that transaction,
Correct.
that set of transactions to the Avail network. So that ordering is taken care of the sequencer itself.
Correct.
But again, for multiple batches of transactions, that ordering still depends on Avail. Because if you send one batch of transactions first and then the other, that ordering also needs to be done. So that is where Avail hand comes in. But essentially, you can also do ordering directly on the DA layer, and this is called as based rollups. So you
Base
might
rollups. Okay.
have
Yeah,
heard of,
base rollups here.
yeah,
Correct.
Tyco and Spire Labs, they're all working on these rollups, wherein they are sending data directly to the DA layer. Because DA layer already does ordering, because consensus ordering is already kind of handled by the DA layer or the base layer. So now what you have to do is you just have to send transactions or data blobs directly to the chain, and the sequencing of those transactions can be directly done by the DA layer itself, and that's how base rollups work. So that's what we've kind of shown here. And then a
Okay.
sovereign rollup is basically just instead of doing the settlement on Ethereum, you can do it anywhere else. Like you can do it directly
It's
on.
a totally independent.
Yeah, it's an independent chain. You can run a sovereign rollup or a sovereign chain on Avail directly itself. So all of that can be done. So it's all like different design archetypes.
So what do you see after getting all this DA implementation? So what do you see the role of the Ethereum going forward?
Very good
I mean,
question.
it's a very generic question, but yeah, I want to understand your idea of where Ethereum is going to stand. Because
Uh,
we are one by one, we are taking out from the Ethereum, right? Um,
right. I mean, Ethereum is not going anywhere. That is for sure. Like it's too big to fail. I'd say. It is currently moving to a more DA-centric roadmap. Obviously, right now there's a lot of confusion on what Ethereum needs to be. I don't know if you guys are following, or if you're on Twitter, if you actually follow all of the conversations by these Ethereum researchers, they themselves are fighting between like, should Ethereum become more DA-centric? Should we be more execution-centric? Should we increase the speed of the execution layer of Ethereum, or should we allow just execution to be done on rollups and just Ethereum being a DA-focused chain? So all of those conversations happen. I think that is also one of the reasons that Ethereum is now trying to push for based rollups on Ethereum, wherein like you still have the sequencing. Instead of relying on a centralized sequencer, you rely on Ethereum as the sequencer itself, and you post the transactions directly on Ethereum, and it's picked up and ordered. And yeah, you have all of those things happening. Yeah, I mean, Ethereum still needs to figure out where it's going. It has multiple different things happening, but I think, yeah, eventually it will become mostly a DA layer. Obviously, it might scale up execution a bit more, but overall, it is right now mostly, trying to become a DA layer, and it will try and support base rollups and app chains more than anything else.
okay, so another last question. Why Avail came out of Polygon and what, like, two different directions, right? So like, or maybe both are converging again, because you mentioned Nexus also coming, Aglair is close to that. So they also might be working on some DA layer also, right? Validium and all those things they have. So I think both are going maybe after some time a similar solutions, but they split, right? What is the reason?
Yeah, I mean, so I think it comes down to the alignment of different things. So like, so when it comes to DLA, right? So being a DLAer, and if you want to have multiple different rollups from different ecosystems, being aligned to a particular L2 does not help you, right? So if Avail was Polygon Avail,
Correct.
it cannot be like most other like Optimism, Arbitrum, ZK Sync, Scroll. These teams wouldn't work directly with Polygon Avail, right? If it was still part, because it's considered kind of like a competitor, you cannot trust it as much. Maybe who knows, right? So that alignment issue comes in from a business standpoint. Even if the tech is neutral, nobody cares about that. To be frank, it's all about the alignment and narrative, right? Second is that Polygon has had so many projects that it was working on at the same time, and it was doubling down on ZK EVMs, right? So DA becomes, so like when it's doubling down on ZK, DA is like it does not meld well with their current brand thing that they're doing. So it makes sense for Avail from a brand perspective, as well as a research perspective, as well as like aligning perspective, to basically just split away. But we still work closely with the Polygon team. Like just because
Okay.
they're different entities, we are not like competitors or anything. We work with them, like the founder of Polygon is the same founder of Avail. So
Correct.
like it's all well and good. It's not like there is any competition happening. Like Avail just wanted to become a credibly neutral entity, such that we can work with everyone, right? Again, the same problem with ag layer is that how many people will use the ag layer because it is Polygon aligned, in a sense, right? In a sense, it is like from a branding perspective or from a business perspective, you're like, oh, it's Polygon thing. Even though they want to, distance itself from Polygon, it is still kind of Polygon's thing. Whereas if we are a neutral entity who wants to provide an interop solution, it has a better chance of becoming such a, again, it's just all about narratives and alignments, I think. But yeah, for Avail, it was more about just being more credibly neutral than being part of a particular ecosystem fully.
Okay.
Yeah.
Yeah, Robin, just before moving for the further Q&A session, we'll just have a small announcement so that if somebody has missed anything in the chat. So we have shared a feedback form for all the participants because we love to hear your feedback. And upon receiving the feedback, we also would be glad to share you the blockchain verified participation certificate. And also there is one question in the chat from Anjita. Is KZG commitment is the only scheme used in the DA layer sampling. That's what she has posted. So if Robin
Yeah.
could pick up.
Yes. So KZG commitments is the only commitment scheme used for the DLA sampling in Avail right now. Yep.
So any more questions, or if anybody finding difficult to talk up, you can just place it in the chat.
DHT, yes, sure. So let me actually do this. So why does this not work? Okay. Okay. Anyway, so where is this? Okay. So what I mean by DHT here is, yeah. So DHT means distributed hash table, right? So what that means is light clients are this P2P network of clients. Yes. Okay. Sorry. So light clients are this P2P network of clients that we have, right? Imagine you have the Avail blockchain, and then it is a completely separate thing is this P2P layer of light clients, basically softwares or clients that are talking to each other, forming a network, a P2P network, right? Now, what they do is they also manage a small database on their end, which is, again, like you might have, if you are familiar with networking and stuff like that, you can have address logs and stuff like that. In the similar way, you have a small database that you're also managing. Basically, it's a hash table but it is distributed. So across all of the P2P clients out there. So now what happens is, as a light client, my only job is to sample the network and make sure that the data is available, right? Now I sample maybe 10 chunks of data of the Avail block. So what do I do first? I want to check if the data is already there in the hash table. Or in the basically, has someone in the P2P network already looked at this data or not is what I'm checking. So what I'll do, I'll first check the distributed hash table. It is basically a database, you can think of it. And I look at the database and I'm like, oh, okay. This data is already sampled. It is already in the database. Okay, now I'll also verify it myself just to make sure it's all correct. So I can do that. That is great. Now, what if I sample another cell and I'm like, oh, this is not there in the DHT. It is not there in the database that I am maintaining myself. Oh, so that means nobody in the light client network has yet looked at that data. So let me ask the full node, oh, hey, full node, can I get the data at this particular, metrics cell, maybe 2:3, right? And I get that data. I look at it, I compare it, I open the KZG commitment at this point and check if the data is available. Great, it is verified, amazing. And now what I do is, okay, now that I've sampled this data and I know that it is not there in the DHT, I'll now write it to the DHT so that every other P2P light client can fetch it later on from the DHT itself. Why are we doing this? We do this because eventually we get the block replica of that entire block. So that so later on, we don't have to fully rely on the full node, right? Even if some black swan event happens, we still have the data behind those blocks with us. Obviously, we prune the data like that. DHT gets overwritten, like basically the data gets overwritten after some point of time. So the light client resources are still small. It doesn't take too much of space because we remove the data after some time. But up to a certain number of blocks, we still have the data available. So that if any case, the full node network is not working, you still have the light clients as a backup. So that's how it kind of works. Hopefully that makes sense.
Yeah, Robin, there is another question here. That's as blockchain developers, what skill set or tools would you recommend mastering to effectively contribute to Avail's ecosystem?
So we are more of a B2B kind of thing. So like we kind of serve rollups as customers. So you would want to be like some kind of a core blockchain engineer to be part to like maybe like spin up a rollup or something like that, but you don't have to. Right now, what you can do is you can contribute to Avail's open source repositories. We've got all of our repositories are open source if you want to contribute to that. If you want to dive deep into rollup stuff, you can look into different rollups. You can talk to me. I'll help you out, and what kind of ecosystems you want to like. You can kind of be a part of. Secondly, I guess like eventually we'll launch Nexus, which is going to be this interop thing, and then once we have that, you will be able to build much more cross-chain applications, and then we'll be more inclined to talk to app developers. Right now, we are more talking to like blockchain core roll-up developers, core developers, rather than application developers. We talk to more of infra devs. So if you're more of an infra dev, this would be more of your area, but we'll soon start talking to app devs because we'll have Nexus and some other things that will be coming soon, such that anyone can build any application using Avail. But either way, we also have a lot of rollups that are being built on us. So if you want to contribute to their ecosystems, we can get you in touch, like Lens, Sophon. All of these chains are using Avail as the DLA. So you can, if you are a dApp developer, you can obviously use them. Or if there is any other use case that you want, wherein you see a use of DA as some outlet of the like some service that we provide is more valuable for you, let's talk and we can see how we can contribute to this.
There is a next question on what kinds of projects or industries do you think will benefit the most from Avail's solutions in the next few years?
Oh, mostly rollups and app chains. I think app chains will App chains are application specific chains. That means instead of writing a smart contract and deploying on any shared public L2 chain, you can define your business logic right within the client, and or like whatever code you want to write, whatever application logic you have, write it directly in the node, and the node kind of runs using that business logic, and you basically create an app chain, right? That might sound complex and too scary for some people, but actually there are frameworks that are being built today that allows any application developer to build a chain. It's a lightweight chain, right? It doesn't take too many resources, like Stacker and Sovereign Labs and Cartesi. So Cartesi is this Linux based environment that can be run as a rollup, and you just have to deploy. You can write your application logic in like Python, Rust, Golang or whatever, and JavaScript also, and you can deploy your application, and that application basically runs as a chain. So I see that a lot of smart contract applications has a lot of throughput issues, bandwidth issues. It cannot scale as effectively. So people start moving to app chains, and rollups or app chains will start becoming the servers of the new world, or microservices. So like you have different chains that focus on one particular thing, and it does that. So I mean, yeah, that's the kind of projects. Industries can be any industry. Like honestly, any application you can build. Yeah, it can be helpful. But right now, like we serve rollups, or the direct use cases rollups, and whatever that rollup wants to solve, that is the industry we'll be in, right? So depends on that.
Yeah, that's another question. If the parties responsible for attesting data are untrustworthy or become corrupted, in this situation, how the trust in data attestation work?
Oh, so the data attestation, you're meaning the data is being attested to Ethereum, is that right, Manish?
Else we can take up another question.
No, I'll answer this anyway. Based on my assumption that you're talking about the data being attested to Ethereum, no external party is attesting it, right? What is essentially happening here is the validator network, which already has a stake. So we have inbuilt palettes, or basically inbuilt code that creates the attestation ourselves, and it is proved using SP1. SP1 is this ZKVM. So basically, there's a circuit that kind of proves that this range of blocks is available. And what happens is now we have a trustless bridge to Ethereum, a ZK bridge that is trustless, that basically sends the proofs over to Ethereum. And because of that, you basically because of that, you're not trusting anyone else. And even if you are, you have a ZK proof behind it. So it should be pretty trustless. Anyone can verify it.
Yeah, so another question is, how do Avail lightlines differ from portal networks?
What are portal networks? I'm not really sure.
Okay.
Yeah, I mean, what do you mean by portal networks? Like, I don't know which project that is referring to. So you could tell me which project you're referring to, then I can look into it, but I'm not sure what portal networks are. So
So we'll take up another question. How will advances in cryptographic techniques impact data availability solutions?
what advances in cryptography? I'm assuming this is talking about quantum stuff that was released recently, but I think we use quantum resistant hashing functions, if I'm not wrong. We use Blake 2B and some other signatures, but I'm not exactly sure if they are quantum resistant or not. So, I mean, if that is the question, I'm not sure, but data availability does. I mean, the KZG commitments are the main cryptographic things that we kind of rely on. I'm not sure if they're quantum resistant or not. If that is a question, then I'm not sure. But other than that, I don't see any other cryptographic advances affecting any DA viabilities as such. I might be wrong. So if you can maybe expand upon the question, maybe I can answer that better.
So, there are a few questions in our personal chat also. One of among them is about privacy and confidentiality, like how Avail ensures that this privacy and confidentiality is taken into care.
No blockchain provides privacy and confidentiality. So in the sense, whatever data that you post is public data. That data is public. So if you want to keep that data private, the thing is, Avail does not interpret the data, right? So imagine as it is a bulletin board, whatever you put on the bulletin board is there for everyone to see. If you want to make sure only certain people can read it, then before you put it on the bulletin board, you have to encrypt it, you have to encode it in some way and put it there. So it's the onus is on the roll-up operators or the people who are submitting the data to keep it private or not. So the data availability layer has no job in keeping it private. That is not the job of the data availability layer. That is upon the roll-up operator itself.
Another question is about, can you shed some light on the current running Web3 projects using Avail?
Oh, Lens. So I don't know if you guys know Lens. Protocol. So Lens protocol is a social network that is using Avail as the DA layer. So yeah, they are on testnet right now and will be on mainnet in January. We have Sophon, XYZ. So this is like a consumer-based chain that is going to be on mainnet on December 18th. So like in a week, it is going to be on mainnet. And then we've got some other gaming chains, which I don't really remember the names of, like Moonwhale.gg and stuff like that. But essentially, yeah, we've got a couple right now on mainnet. And we'll be closing, like right now, most of them are on testnet. We've got Skate Chain also. So I don't know if you know Skate Chain, skating.org. So this is a chain that is on mainnet right now on Avail. So again, right, like I said, we kind of serve chains, and then the chains on top have their own ecosystems, and these chains basically use Avail underneath, right? They submit the data back to Avail. So yeah, that's what we do, right? Skate is on mainnet right now. Lens and Sophon will be in mainnet in a couple of weeks. So yeah.
Any more questions from the participants?
I think I saw a question on, can you explain KZG commitment up top? So KZG commitments it's basically cryptographic. It's like a precursor to validity proofs or ZK proofs. It's a commitment you first generate before actually creating the ZK proof, if I'm not wrong. But I am not a cryptographic expert to explain exactly how KZG commitment works. So I can give you resources though. So if anyone wants to, read more into any of these terms that I have mentioned, ping me on either Twitter or Telegram. My Twitter is Robin RRTX. I can actually post that in the chat. Or my Telegram is, and I mean, you can find me on LinkedIn also. That's fine. My email is also, I guess, available to everyone if I'm not wrong. But yeah, mostly I'll be available on these two platforms, Telegram and Twitter. Yeah, this is my Twitter. So, yeah. Follow if you want to, but but yeah, it's not something I want. Yeah, so I can send any resources if you want to learn more about case commitments. It's basically validity proofs.
So if there are no more questions, then we would wrap the session. So thank you so much, Robin, for being with us. And thank you so much for the information you shared. It was quite insightful. And there are a lot of more questions among the participants also. And we are quite excited about hearing from them also. So all the best for all your ventures, and we wish to look forward for further collaborations and engagements. Thank you once again.
Thank you. Thank you for having me.